Okay, ma'am. So these are the things about the foundations of learning, unit one. So learning, as you know, differences like what is meant by basic definition of learning. Okay, and how it was like specified with many scientists or also the inventors. Okay, like Albert Seaman, Marvin Minsky, and Reza Minsky. Okay, so different. As you know, we have unique ideas, human beings. So different perspectives of learning. Okay, so normally machine learning refers to a system capable of autonomous acquisition and integration of knowledge. Okay, so like we normally in the machine learning we'll be having the testing and training data. So what we are doing, we are just feeding the data and the system based upon our model, it will be giving the results. Okay. The next one is traditional programming. So the various difference between traditional programming and the machine learning. So I think we already know it. So why we need this machine learning topic or the subject? So these are different things like no human experts, black box, human expertise, rapidly changing phenomena, and need for customization or personalization. So these are the main things why actually the machine learning is required. Okay, like autonomous driving is there, Tesla car is there. So what are the features in that, and how machine learning is being fed into that complete model? Okay. So this is collection of all the fields, like or you can say related fields, like data mining also is involved, statistics, data mining in the sense decision trees, okay, ID3, again decision trees, random forest, all these are from data mining algorithms only, and these are implemented in the machine learning. Okay, statistical tools are there, and for IT databases. Okay, like you have seen the week two program, how we can retrieve the databases through Python. Okay. Next, evolutionary models, because the way the system or the complete project has to be developed, it will be in the form of evolutionary models. Okay. Next, you have neuroscience, psychological models. So these also all the related fields in the machine learning. Okay. So this, as you know, it's concerned with normally what in the projects you'll be asking what is the accuracy you have obtained and how much performance, what you say, performance improvement from various algorithms you have got, and also you can see like from where you have gathered the data set. So these are the basic questions in the when you consider with the project. Okay. So here normally machine learning is primarily concerned with the accuracy and effectiveness of the system, and these are the components of learning. Understand the difference, types of learning is different, again components of learning. So these are the basic components of learning, as collecting and preparing data, choosing and training a model. Okay, which model is efficient depending upon the data set. Okay, like if you have image data set, so multiple images means we won't be able to use the machine learning thing. Okay, we'll be able to use, but if you have thousands or millions of images, then it will be in the deep learning. Okay, so it depends on the type of the data set. Okay, next, evaluating a model and hyperparameter tuning and prediction. So these are the components of learning. So in the example you can just expand these topics in your own words, just write these headings only, but you can expand in your own words. Okay, again differences you can be asked, like differences between geometric, probabilistic, or logistic logical models and all that. Okay. So geometric, as you know, is based upon the axis, x-axis and y-axis, or 3D if it's considered, then z-axis. Okay, so you can see like planes or so segment, or you can say the classification in the instance. So this is also called as linear models. Okay, so because it has some lines or planes, so it is called as the linear models. Also it's called, also it's renamed as distance based models. The geometric models, if the question is asked like write about the distance based model, so don't get confused. No, you need to write about the geometric models. Okay. So in again this probabilistic models, okay. So these see the futures and target variables as random variables. So the process of modeling represents and even manipulates the level of uncertainty with respect to these mod variables. And again we have two types: predictive probability model, and also we have generative. Okay, based upon the probabilistic. So best example is naive Bayes classifier for classifying the you can say entities. Okay, so as you know we have some levels in this, and also we have some margins. Okay, so it's based upon the condition probability even. Okay, So here we can see we have a joint distribution of P of ix. Once we know the joint distribution for generative models, we can derive any condition on marginal distribution involving the same variables. So this is the thing about probabilistic models. And last one is logical models. So again, in this we have two types, that is tree models and rule-based models. So as you know, I think AI you have studied the if then rules will be implemented in these types of models. Okay, the logical models use logical expression to divide the instance space into various segments and also constructing the grouping models. Okay, so logical expression. Okay, let me enter uh, the waiting room. I think people are there. Okay, admit GMR. Okay, fine, man, fine. So logical models, as you know, we have a expression, I think with returns a Boolean value, either true or false or zero or one, whatever. Okay. Like in the prologue, you are getting like yes or no, or sometimes true or false. D7 from D7, mute yourself now. Okay. So we have two types of logical models, the tree models and rule models. Okay. So rule models consist of the what you can say that is called as if then rules. Okay, if condition then another condition, what is that? Okay, that we need to monitor it. Okay, yes ma'am. So rule models consist of collection of implications or the if then rules. Okay, if part then part. So as you know, if condition then what is the next step, like that. Okay, so rule model consists of collection of implications or if then rules. So for tree based models, the if part defines the segment and the then part defines the behavior. Means if this is the action, what is the behavior? Okay, so rule model follows the same reasoning. So again, we have tree models, as the name indicates, it's some form of tree. Okay, so tree models can be seen as particular type of rule models where the if parts of the rules are organized in the tree structure. So like tree, as you know, we have root node, leaves, like that. Okay, both tree models and rule models use the same approach to supervised learning. Okay? The next one is about the learning models. Okay, so here it was like various learning models. Again, we have grouping and grading models. So this is also a type of learning models. Okay, this one did you doubt still now? The student, anyone respond? Any doubt still now, ma? Okay, fine. So grouping, as you know, like group and grade. Okay, suppose we have various colored balls. Okay, so grouping means what? Keeping in some groups. Okay, like green color board in one bag. Okay, yellow color balls in another bag, and red color balls in another bag. So this is called as grouping. And grading means what? Grading, just giving them some rank. Okay, it is called as grading. Okay, or grade, applying the grade. Okay, based upon the things. So here the key difference between grouping and grading models is the way they handle the instance space, or you can say x-axis, y-axis, and even z-axis, like that. Okay. Yes.
వాట్స్ అన్నా తెచ్చుకుంటా అయిపోయేది ఎంఎల్
So grouping models break up the instance space into groups, or you can say the segments or parts, or simple words, even you can say subgroups of subsegment, like that. Okay. So the number of which determined at training time. So how many segments are there? How many columns are there, or else, like that. Okay. So they have fixed resolution and they cannot distinguish instances beyond the resolution. So means something limit is there, and you cannot distinguish again beyond it. Okay, like that. Next, At the finest resolution, grouping model assigns the majority class to all the instances that fall into some segment. Okay, so and its finest resolution means exact output, if you can say. Okay, grouping models assign the majority class to all the instances, like whatever instance 1, 2, 3, 4, like that, all the instances which falls into the particular segment. Okay. And next one is determining the right segments and labeling all the objects in the particular segment. Suppose we have some kind of machine learning or computer vision based project where we need to give the labels for the objects. Okay. So as we know that it will be kept in a bounded box and it will be named or labeled. Okay. That is the thing. Again, next one. Tree models. So tree models repeatedly split the instances space into smaller subsets, the subparts you can say. Okay. So trees are usually of limited kind of thing or limited depth that don't contain all the values. Okay. And next one we have, what is it now? Trees are usually of limited depth, don't contain all the available features, like whichever are important features. Okay, that will be considered. Okay. And next one we have subset. Okay, what is that subset of tree? Okay, the subset at the leaves of the tree partition the instance space with some finite resolution, and here the instances are filtered into the same leaf of the tree and are treated the same regardless of any features not in the tree that might be able to distinguish them, means which might be able to separating. Okay, means like simple thing, like whichever is already there it must not be repeated. Okay. Next, we have the grading model. So it's based upon the Cartesian instance space. So same like suppose SVMs we have. Okay. So this do not use the segment of segment notion of the segment. Okay. That is the thing.